Well, hello, everyone. Welcome to Open Hardware TV, Season 3, Episode 1. I'm Rick O'Connor, President and CEO of the Open Hardware Group. And in today's episode, we're going to do a year in review for calendar 2021 and just talk through some of the events in the industry and progress at the Open Hardware Group ecosystem. And as we've done with previous Open Hardware TV episodes, we've pre-recorded the actual interview that they had from EE Times. And I have a fireside chat style interview, lasts a little over 30 minutes. So we'll live stream that pre-recorded video now, and then Nitin and I will be back live with you to take your questions and hopefully have a lively Q&A chat at the end of the pre-recorded session. So we'll see you in about 30 minutes. Thanks for joining us. Hey, well, hello, Nitin. Welcome back to Open Hardware TV, Season 3, actually. And Happy New Year. Good to see you.
Hello, Rick. Yes, and Happy New Year to you too. Hope you've had a good year.
Yeah, it's been interesting, to say the least. Looking forward to our chat today, which is, the third time we've done this, right?
Exactly.
The first time was just one-on-one, no cameras, no nothing, at High Peak in Bologna back in January of 2020, which, as it turns out, was my last industry travel event.
Yes.
And then, of course, we did this last year. So this is the third season of Open Hardware TV and our third year of operation here at the Open Hardware Group.
Well, congratulations. So let's get straight in. We're here 12 months later since we last met virtually. And I'm just wondering, let's just sort of look up at sort of 30,000 feet level. What's been interesting or exciting in the industry, or sort of what's been quite significant from your point of view, not just from Open Hardware, but generally in the industry over the last 12 months. Any thoughts?
Yeah, a few things. One is really just momentum around the notion of open source hardware, independent of Open Hardware Group activities, but just open source hardware in general. The idea that is a possibility, beyond a possibility. I think we've transitioned past the curiosity to enough existence proof around a number of different initiatives beyond the Open Hardware Group, which we'll talk about in detail, I know, but the activity at Chips Alliance is significant. The activity with the low-risk guys have underway is significant. The Open FPGA Foundation that got started in the last year is significant. There's just a number of different communities and activity underway that really underscore the fact that this curiosity, or beyond now curiosity, of whether or not open source hardware can play a role in the hardware industry is really starting to take hold. So, on the one hand, you could argue that, well, geez, all of these different communities make it harder. Where do I go and what do I do? But they're all slightly different. They serve a different purpose and have a different set of priorities. And generally speaking, the people that want to participate kind of self-identify and engage in the communities that they're interested in. So I think, a significant thing is just the simple fact that there's that much activity underway across the industry, exploring open source hardware right down to the fab.
Okay, I think from my point of view as well, over the last 12 months, I've seen a lot more realism come into sort of that whole sort of open hardware, the processors and the systems that are being developed, and acceptance of the fact that there are things you can do, both sort of mixed, heterogeneous, but also at the same time, just enabling the whole ecosystem around it. So I think it seems to be moving on beyond maybe what we were talking about 3 years ago when we were saying there needs to be a lot more done, when you were just sort of thinking about open hardware.
Yeah, I mean, when we met in January of 2020 in Bologna,
2019,
right?
2019. Oh, 2020. Yeah.
No, it was 2020.
2020.
Yeah,
yes,
it was.
Right.
It was just before all the lockdown nonsense, right? So,
exactly. Yes.
it was really 2 years ago, but the start of our first year and now the start of our third year. So we had just incorporated the nonprofit in the mid 2019 and spent the latter part of 2019 defining the governance framework, IP contribution rules, membership language and bylaws, and how the nonprofit organization would be constituted and governed, and really just got that finished at the end of 2019 and started to be operational, if you will, just when you and I met really in January. So we were really at the front end of, okay, we're fixing to get started, so to speak, and just getting started. And then, had that first year of operation, and then now a full 2 years of operation under our belt as we head into year 3.
So we actually have, I think I've got quite a few questions to sort of put through to you. So let's get cracking. That actually leads us very well into, so let's talk about the OpenHW Group growth from over the last 12 months. Whatever you want to cover, into members and partners, or what things people have been requesting, or new working groups. Let's just maybe do a little bit of a catch up, a summary.
Sure. Depending on how you want to measure it, what metric you want to use, whether it's members, projects, activity in the task groups, we've more than doubled in the last 12 months. We're sitting now at 80 members and partners that are formally engaged. Many other engagements that are just part of open source contributors as individuals, but this is institutions, organizations, both commercial and academic institutions involved in the open hardware ecosystem. We went from really one project, in year one, completing the validation and verification of our first core, the original risky core out of ETH Zurich,
yes.
Which we call the CVE4, embedded 4-stage class core, and completed that validation at the end of 2020. December 2020, we reached RTL freeze. And the focus in that first year was really figuring out how to have all of these contributing engineers from different companies work together, define the process, engineering release methodology and development process of doing this work in the public domain, while also using that process and completing that first project. And then since then, the roadmap for the Core 5 cores, so Core 5 is the brand name that we use for the open source RISC-V cores in the community. There's 9 different cores on the roadmap now. We had a few, one project with that 32-bit core and a few cores on the roadmap, but there's now 9 different cores, at least 5 or 6 of which are in active development currently. And the amount of work underway, in the cores projects, the task group for the cores themselves is one thing, but the verification infrastructure that we have in place is significant and getting quite a bit of attention in the industry, as well as all the different software projects that we have underway to support the cores. And whether that's GCC, LLVM work, RTOS and operating system porting with FreeRTOS and Linux, IDE development for bring up environments and so on. So the activity is, there's probably 20 some odd different projects in flight across 5 to 6 different cores. And it spans everything from the RTL, obviously itself, right through to silicon implementations, right? We're continuing to work on a device called the Core 5 MCU, which we'll be taping out here at the front end of 2022 with Global Foundries, and producing development kits for distribution into the ecosystem later this year. So lots of activity over top of what we did in our first year.
And is that driven by obviously member requests, or how does it work?
So you're talking about the MCU specifically, or
no, generally the projects.
The projects.
Yeah, the projects.
Right.
Yes.
Right. So the activity that we have underway at Open Hardware is truly open source, right? It's permissively licensed. You could go on the GitHub repos yourself and download all the artifacts that are being produced by the projects without ever talking to anyone, joining the community as a member or anything. It's permissively licensed. Solderpad and Apache and Eclipse Public License are the licenses we use. Go ahead, have at them. The membership benefits arise from the ability to participate in the projects that we're defining, the features, the functionality, the priorities, and what it is the contributed engineering resources will work on. That's defined by the members. It's not me or anybody on the Open Hardware staff, any single individual that decides what projects get worked on. It's driven by the membership. So the members, if your company is using these open source artifacts in a production revenue generating product, there's benefit just from your own strategic purpose. So there's benefit to having your hands on the steering wheel a little bit, sort of help drive the direction and guide the outcomes of these projects so that they meet your requirements. Okay, and in terms of, you mentioned some specific things, but are there any specific trends that you've seen in the projects being requested, or is there something that you can say, okay, well, there's something going on in the industry that says everybody's looking for this or everybody's looking for that, or is it still across the board? The focus and community that we're fostering and building is very much on ensuring high quality RTL implementations that fit nicely into their existing tool flow, their CAD tool development flow, so that they can not change anything that they're doing other than, if you will, pick a different vendor for the IP that they're using in their SoC and have it fit into the work that they're doing seamlessly, and leverage their existing infrastructure that they already have. So what does that really mean? Well, we need to produce high quality, commercial grade, well verified RTL that works well and nicely, if you will, with commercial CAD tool flows, right? So we have engagements with the Mentor team, Siemens team as a member, and Cadence and Synopsys as partners. And all of the work that we do is System Verilog UVM based. So it's well-written RTL in System Verilog. We're not trying to tell our members that they need to use a different HDL or the synthesis language. We're not trying to tell people to use different tools. The tools they want to use is where we should fit into. And as you'd expect from a commercial grade IP vendor, you need the high quality RTL. It needs to be well verified, but you also need to see all of the tool infrastructure from a software standpoint and a bring up standpoint supporting those cores. You need to see reference kits and development kits in current geometry, deep submicron technology nodes. So Global Foundries 22FDX is where we're building the Core 5 MCU. So we're trying to create a open source collaborative ecosystem that looks like, smells like, feels like what the engagement you'd expect to see from a traditional commercial IP vendor. Okay. So those are the things that our community is asking for as they engage. Our members are asking for as they engage in the community. Just make this seamless for me. It's another vendor choice. Just happens to be an open source nonprofit vendor that they're integrating. Interesting. I was going to go into goals for 2022, but let's stick to the end for that. Let's then follow on from what you've just been talking about. Maybe a review of some of the projects you've completed over the last 12 months. So might be useful just to highlight something like Core 5, Core V cores, software development kits, or any other sort of tool flows specifically. Quite interesting to maybe just cover some of that. Sure. Well, probably the most active project is where all the cores sort of end up coming together, not from a functionality standpoint, but from a verification infrastructure standpoint. So that the verification task group is probably one of our largest task groups in terms of the total number of contributors. And is also a task group that touches every core, obviously.
Yeah.
Because that's where the cores go to get verified. And what's been interesting is that, like I said earlier, we have probably 5 or 6 different cores in active development right now within the ecosystem, and they all leverage the same verification infrastructure. Obviously, there's differences depending on the device under test that you need to implement into the test bench. But we have a test bench called Core 5 Verif, appropriately named, I suppose.
Why not?
Core 5 verification. Yeah, why not? Right? Very creative. So Core 5 Verif, has a traditional sort of software repo hierarchy set up with a master branch, release branches, and then development branches that get forked out depending on the cores being tested. And then changes that get made to the test bench come back up into those release branches and then the master branch. So the Core 5 Verif as a RISC-V test bench, forget about our Core 5 cores. But Core 5 Verif as a RISC-V test bench is continues to grow and get more comprehensive and stronger as a verification tool as more cores are being verified through it. And we have several members who are engaged in the community to use Core 5 Verif, not with the Core 5 cores, but with their own internal proprietary core development that they're working on. It's becoming, we believe, and this was sort of a second order goal. The first order goal was to have a high quality verification infrastructure for our Core 5 cores. But the belief from the get-go was, if we do this right, this can become the de facto standard for how to verify any RISC-V core, not just these open source cores.
That's actually a very good objective.
Yeah, and it should fall out of the soup, if you will, or fall out of the wash if we do it right. Right? If we execute properly against the Core 5 cores and the mandate to provide industry grade verification, swap the dud out, swap out the device under test, put your own in there, reuse the rest of the infrastructure, run it on obviously your own CAD infrastructure and your own CAD tools, and away you go. And we're seeing that, and we expect to build on that. We can talk about that later if you want to talk about goals for the year, but we expect to build on that this coming year.
Okay. So I think you've pretty much answered what the key one, which is Core 5 Verif. But anything else around that? Maybe the SDKs or anything else? Or
well, we're getting to the point of taping out the Core 5 MCU, and this will be a live SoC with open source from the RTL right down to the gates at the core level. That is a quite a relevant, production ready, low power IoT edge class embedded device. We are in the process of defining what those hardware development kits, software development kits will look like that will go on top of that. We should be in fab, early this year. I don't want to jinx anything. And as we make that progress, we'll be making more announcements into the ecosystem of what this will look like and how people get their hands on it. But the idea is that we will have an IoT, low power IoT edge class device that has cloud connectivity, that you can upgrade the firmware in this device over the air. None of it is really groundbreaking technology in terms of what's available today, but nothing like this is available open source. So not everything will be open source in it. I mean, we have a healthy, I think, respect and relationship in marrying the open source IP blocks with proprietary IP and proprietary tools, as we talked about earlier, the commercial CAD tools. to do the best job, use the best tool and best IP for the job, right? So, not everything will be open source, and that's okay. We're pragmatic in the approach, but it'll be we believe a significant release into the industry when we roll this out sort of mid 2022.
Okay, I mean, that sounds exciting.
We think so.
It would actually be, I suppose, it's quite possible to, put some sort of open connectors or something like that, just to enable a lot more people to then enable, to use that, I guess.
I kind of take it on the chin sometimes. I think we've talked about this before, that from some of the open source purists. I mean, here we are as an open source ecosystem, and I'm the guy that's leading it, and I'm about to say that not everything's open source, and that's okay. So I kind of take it on the chin for that from time to time from some open source purists that believe that if everything is an open source, then nothing is, and that's just not pragmatic, right? In today's hardware world, right?
But you know what? Yeah, there's an important, I think, lesson there, and purist doesn't make you a commercial success. So I think you have to look at it that way as well. So you have to be pragmatic.
Yeah, well, that's interesting, right? Because from the beginning of creating the Open Hardware Group, back in their 2019 stages of forming the group, that was definitely one of the mandates, or certainly one of the targets, that this will not have any sustainability and longevity unless there's commercial success associated with adopting these open source artifacts. Unless the very large commercial SoC companies are at the table, this will not have longevity success. And so that's been that's how we got down the path of, hey, all of this stuff has to run on commercial CAD tool flows. All of this stuff has to sit and play nicely with proprietary IP sitting right beside these cores of the SoC. We're not trying to solve world hunger or, I always say boil the ocean with a single match. It's just not practical or pragmatic to do so. We'll use the best tool for the job and marry up the IP against the best IP to produce the platforms that we need to produce, and encourage, not beyond encourage. The whole point of this is for commercial adoption and leverage.
Yeah,
right?
exactly.
If the members can't leverage this stuff commercially, then who cares?
That's absolutely right. I mean, I actually learned that from 1990 when my dad was trying to do a PCB manufacturing company. And the purist in him, didn't want to sort of bow to certain things. And that's why, we didn't succeed. But that's how it is.
Yeah, some people view large commercial companies involved in open source projects as it's just like, no, it's no, it's, and it's like, if you look at it, so arguably Linux is probably the largest example of a successful open source project that the whole world clearly knows about, even if they're not in the tech sector. Yeah. And I mean, there are countless examples of commercial successes built around Linux. And the most interesting or obvious one that people can reference all the time is whatever it was, $31 or $34 billion acquisition of Red Hat by IBM a few years back. Yeah. Right. So that was 20 years in the making. So hopefully we'll have a commercial impact at that size well before 20 years from now.
That was going to be one of my later questions. What's the impact? But I think is there anything else you want to say on the sort of projects completed over the last year, or should we move on to goals for 2020?
Yeah, maybe just a couple more comments on. We made the RTL, declare our RTL freeze milestone right at the tail end of 2020. And while we do not require anybody to disclose what they're doing with the IP, there are several different instances of full production releases that leverage that core that we know have occurred. It's not our job to do any product announcements for anyone, which we don't do, obviously. If anyone wants to make noise about the fact that they're using these cores, they're more than welcome to do so, but there's not a requirement to do it. But yeah,
and they can tell us as well. I mean, they can tell the media as well.
Yeah, I'm probably lining up to do so. That
was an open invitation, by the way, to our audience here.
That's very good. So I think the point is that adoption is ongoing, and these artifacts that are being produced out of the OpenHW Group are being used in high volume production SoCs.
Okay, well, good. Let's go to your target goals for, well, not targets, just, what do you want to achieve in 2022? It's always difficult to put a target or a goal, but, I guess, you have some objectives set by your board, your membership, or yourselves.
Yeah, and, for sure, sometimes it's challenging to put those kinds of targets out there, but I'm a big believer that, if you go out for a walk and you don't have a destination in mind, then you're just wandering around. You'll never be lost because you're not.
That's what I'm doing wrong. I'm aimless.
You're never going anywhere. You have no destination in mind. So even if you have to change the path because you've decided to change your destination, the sooner you realize that, the better off you're going to be. So setting an outcome is important. So we think we fundamentally know we're going to continue to grow, probably at the same pace. It's not going to be a doubling. With 4, 5, 6 new members a quarter easily, we'll be easily over 100 by the end of the calendar year. Right. Members and partners. The Core 5 MCU platform and the development kit around that, both early on in FPGA, emulation kind of format, and then the actual SoC. Yes. As we get parts back from the fab, built in at Global in 22FDX. That'll be a significant milestone, and the enablement around it, because it's not just great, we got a core, but a core that's integrated into a functional a microcontroller SoC with all the software tools and operating system support and network connectivity and hardware development kit underneath it. There's a lot of work that needs to be done in order to enable that effectively. And so that'll be a significant milestone. And we have a bunch of very, very interesting activity around our 64-bit core, the CVA6, which is originally the Ariane core out of Luca Bedini's team at ETH, where we'll be looking at coherent clusters of that core, are continuing. There's work that's ongoing now around that. That'll get mature much more. There's lots of activity and interest around chiplets, and supporting chiplet infrastructure with some of these clusters. So that'll be a significant activity for the year. And something that we did right at the tail end of 2021 was start down the path of our global footprint with the creation of OpenHW Europe and OpenHW Asia. So as you might know, the OpenHW Group is a Canadian federally registered nonprofit. And from the beginning of creating the ecosystem, there was an intent to have a legal footprint in Europe and have a legal footprint in Asia. We're starting that process with OpenHW Europe Working Group and OpenHW Asia Working Group, both as registered working groups within the Eclipse Foundation, registered in Brussels, right? So this is a legally independent working group, but if you think about it from the context of like a multinational conglomerate that has legal operating companies all over the world that legal structure-wise are independent, but operationally in terms of how they function, it's one operational global organization kind of format. And that's what we've done with our partners at the Eclipse Foundation. As you might know, the Eclipse Foundation moved their headquarters to Brussels a little over a year ago. And we're leveraging that infrastructure to create these working groups as parallel working groups to our technical working group and marketing working group within the overall OpenHW structure, and be able to represent the European community as well as the Asian community in the priorities and projects that are executed globally.
Just for the purpose of some of our audience maybe don't understand why you need, in a world of global collaboration, why do you need those specific legal entities? Just in overview. We don't need to go into the detail.
Yeah, no, it's an important consideration. To be honest, the very first question we get was, "Well, what's that about? What are you doing there?" So and it's interesting, right? So I take it back to a lot of the challenges that we saw when creating the Open Hardware Group to begin with. What challenges were we trying to address? And one of them, and probably the most significant one, is critical mass, right? We need to be able to rally the community around handfuls of implementations that they are comfortable with, not just from a technical standpoint, but from an accessibility standpoint, from a security of supply, if you will, standpoint, longevity standpoint. All kinds of factors come into play. But that critical mass is an important consideration to actually having enough adoption behind these open source artifacts such that their longevity and existence is almost a self-fulfilling prophecy, right? So,
and you need the legal groups for that to happen, or can it not happen from Canada, for example?
Well, it's just another comfort point, right?
Okay.
So we're living through a couple of years of history here of some pretty unpleasant geopolitical unrest in different parts of the world, right? And that scares people, right?
I see. Yes, true.
And rightfully so, right? And also, just in terms of federal policies, national government federal policies. So here in Canada, I think, as you know, we talked about this before, we have a $22.5 million research funding program from the Canadian federal government as part of the Open Hardware Group activities, where we can fund industrial projects. And clearly, that's political money that the government wants to spend in Canada.
Yeah.
Same is true for the European Commission. There's this national sovereignty, national digital sovereignty, that people are starting to really understand now. If they're going to invest in open source artifacts, they want some confidence that the stuff's going to be available, to their constituents. So it's just all making sure that everyone's comfortable that an open source model can work. It can work. The engineers are already there. They're already happily collaborating globally, and that's fine, right? So it doesn't change their life, and that's usually where the questions come from. Like, what do we need this for? We don't need this. But it's above that, right? It's more around just the existence of all of these projects and the output of these projects not being encumbered by any single organization or any geopolitical influence.
Yeah, I think I can put it better for you and make it easily accessible to the wider sort of regions. Yeah,
and like I said, down at the engineering level, they're going, I don't have a problem. I'll just get it off GitHub and I'm all set. But it's a little more there's a little more to it than that.
And one of the other goals for 2022, I guess, is to. I'm guessing open source is still something that people are a little bit scared of. So educating people on on what you're doing, but also on how open source can help globally. I think that's one of your goals, isn't it?
Yeah, we'll continue to do things like this and more Open Hardware TV events, and hopefully someday we can all get together for industry events again. But yeah, there's a lot of activity just around, and this is interesting, where we've got a bunch of the open source communities collaborating together to help just increase that comfort level, disseminate the knowledge that yes, you can use and leverage these open source artifacts in your products for commercial benefit. It's safe to do so. Here's how you collaborate. And there's like I said, at the outset, a number of different initiatives that exist independently that are helping to push that forward. And we work hand in glove with a bunch of those folks to make sure that we're serving the people that we say we want to serve.
Okay. So, we've covered your growth from 2021. We've covered key projects. We've covered goals. What do you think? What impact do you think the Open Hardware Group has made in the open source community? I think you've covered some of the connections or relationships that you've already forged, but ultimately, so is there a sort of bigger impact you're seeing?
That's a tough one, especially when we're all
sorry to put you on the spot.
Oh, that's okay. Just especially as we all sit by ourselves behind our Zoom screens or WebEx or Teams or, oh my gosh, you name it, the different things that we have to talk to each other on. But despite that, right, despite that lack of closer connectivity, we've really seen that the projects, as people become exposed to what we're doing and what the community looks like, that watching the transition of, that's not possible. That's just not going to work.
Oh, really?
Well, we're doing this, and we're doing this, and we're doing this, and we're doing this. And even for some folks, I mean, there's some companies that I've been talking to, well, since I started the RISC-V Foundation, right? So 2015, around this is coming, this is what's going on. And they're still deciding whether they're still on the deck of the pool. They're not in the water yet, right? They're still deciding if they're going to wade in. But what's been interesting is they've observed the trajectory along the way, right? And they're gaining confidence that, this is, not just a curiosity. This is an idea that has momentum and is ready to be adopted, right? So I think the impact that we're having for the folks who aren't in the water yet is that we're changing minds, right? We're starting to really have go from that's not possible to, hey, look, this is happening over here, and it might be for us someday. And then eventually we'll get to the point where no one even raises an eyebrow that you're running a Linux operating system on a web server.
So taking that analogy, the water's warm enough now for them to sort of like go and take a little bit further in. Soon they'll be diving in.
Yeah, they might have decided to wade in ankle deep in the shallow end and go, you know what? Hey, this ain't so bad. But they haven't committed to anything yet. They certainly haven't jumped in the deep end. They're not afraid of the pool anymore.
Interesting. Was there a defining moment for your group in 2021? I know you outlined quite a lot of things that have gone on. There must be something that you feel proud of, or something that it was, something that sort of says, okay, well, this is a defining moment for the group itself.
I think it was really sort of the tail end of 2020 and into 2021 where we transitioned from basically a one-trick pony, right? With all hands on deck, one core, one development flow, figuring out how to work together in 2020. And then boom, right? Exploding that into like 9 different cores on the roadmap, leveraging the flywheel, the momentum behind the flywheel, if you will. And these 5 or 6 different projects that are under active development over the course of 2021. So that transition from single project, all hands on deck, figuring out how life works, if you will, as an open source, public domain based collaborative engineering environment, to multiple projects in parallel, sharing and leveraging those resources. That flywheel effect, I think, has been pretty significant. And there's more of that to come.
Okay, so we're going to end it now and say, personally for you, I mean, do you feel a sense of achievement now in the 3 years that since you've set up? Do you feel like this is something it's taking fruit, taking shape?
Yeah. I'm proud of the fact that we grew the RISC-V Foundation to the extent that we did before I left, and I'm very proud of what we're doing here at the Open Hardware Group as well. And in particular, that this is happening without the benefit of conferences and workshops and face-to-face activity and so on, because launching any new initiative during these times is difficult. But clearly, I think the focus that we have and the direction that we're trying to establish has hit the sweet spot with a number of companies And that's, just a testament to the growth that we've had in that time frame. So I'm really pleased to see that activity, and I can't wait to get together with everyone, have a beer and make more progress.
Maybe in a few months we will. So Rick, it's been great talking to you.
Oh, it's always my pleasure, Nitin. Thanks for doing this.
Thank you.
Well, thanks to the attendees for watching that with us. Nitin and I are live now, and we'll take your questions. Please go ahead and enter your questions in the chat box or in the Q&A panel in the webinar platform, whatever you're watching from on Zoom. And we also had a bunch of questions that came in during the registration process. So we've got a few queued up already. And so we'll just get right into that. Nitin, I'll let you take it away, and you can put me on the spot. And to the attendees, feel free to do that too. And you should ask questions of Nitin too. So it's not just all about Rick being put on the spot. So
yeah,
what do you got, Nitin?
Good. Yeah, good. So yes, welcome back. And thank you all for watching, listening, and asking questions. So I'm going to kick off. The first question we've got from Andrea Vitati, and he's asked, do you use or plan to use OpenLane or other open tools for your flow? So Andrea, I know you're keen to ask that question. So there we go. Rick, over to you.
Yeah. So a good question, Andrea. And we get, as I said during the Fireside chat, we get the question a lot about open source tooling versus the commercial tooling that we use and adopt. And the short answer is we will use whatever tools our members want us to use. And when I say we, I'm really referring to the ecosystem, not me personally or the open hardware staff that we have that supports the projects. But our members drive what the projects are and the features and functionality and the flow associated with the projects. And from the get-go, the focus has been making sure that the IP that we are developing fits into their existing CAD tool flows. And arguably 95%, probably even higher, of today's production silicon that's in production, right, has been produced using commercial CAD tool flows, probably written in System Verilog and verified in the UVM flow. And we're not trying to change that, right? We're in my past life, in a semiconductor company, it was a fireable offense to go into your boss's office and suggest you wanted to change the CAD tool flow. Once it's known and produces known good silicon, then with first pass success, right, bug-free silicon, then you don't mess with it.
Yeah.
We think there's lots of cool work being done with open source tooling, tool flows, and so on. We don't, we're not driving any of those projects, and maybe we'll use some of those tool flows down the road, but that's entirely up to our membership, right? The focus that we have is getting these IP artifacts into high volume production and verified the way that our existing members expect them to be verified, and that means using commercial tool flows today.
Yeah. Andrea, I hope that's answer your question. If not, please do raise your hand again or put a question in the Q&A. And yes, as a reminder, anybody else has any more questions, please do put them in the Q&A. On to the next one. So this is from Klaus Strohmeyer, and he's asked, what is the progress on the extension interface and are companies using it? Right. Okay. Yeah, we didn't really talk about that at all during the Fireside chat. But so what Klaus is referring to there is a specification effort underway. It's one of the projects in the open hardware ecosystem called the Core 5 Extensions Interface. And if you step back for just a second, one of the key benefits of RISC-V as an ISA is that it's a modular ISA grouped into functional extensions of the ISA. And one of the areas is user-defined instructions, so a reserved opcode space that will never be trampled on by the main specs for user-defined instructions. And
that's all well and good, but how do you really leverage that and make custom accelerators with your own secret sauce instructions, and then attach them into a core infrastructure? So we set about in the ecosystem, in the open hardware ecosystem, to develop the Core 5 extension interface. It's being developed and used at the same time. So there's a bunch of the cores that have the extension interface being designed into them, the CVA6 variants. There's a E40X variant, so that's a derivative of the original RISC-V core, embedded 4-stage class core, CVE4 family. And we'll continue to see progress against both the spec definition and the implementations, and expect accelerators to be able to attach to those cores more easily. And we'll also have our own sort of open accelerators that will attach to those cores as well. So there's lots of activity around the Core 5 extension interface. So if you want to follow along, check out the GitHub repos and reach out, and we can get you plugged in.
Sounds quite comprehensive. Can you give us a picture of how OpenHW Group will help coalesce the global industry around a reasonable number of open source cores? And I guess reasonable is is a key word there.
Yeah, and it's kind of challenging because on the one hand, and I got this a lot when I was running the RISC-V Foundation. The more, the better, right? I mean, a free and open ISA instruction set architecture is a wonderful thing. It lowers the barrier to entry for anyone who wants to play around with, processor microarchitecture designs and so on, right? Nitin, you and I could start banging on a core and create something in your kitchen, this week, throw it up on GitHub over the weekend, look at this, here's our core. And that's awesome, right? So, hooray from a pedagogical standpoint, a teaching and a learning standpoint, and an innovation standpoint, those barriers have been obliterated. They've been removed, which is fantastic with the advent of a free and open ISA, the RISC-V ISA. So great, the more the merrier. But when you sit back and think about it for a second, too many is a thing. The enablement, if what we're really trying to do is create credible open source implementations in particular, the enablement of the ecosystem requires critical mass adoption of a handful of implementations, not dozens and dozens or hundreds of implementations. We'll bifurcate the limited available resource globally and chop them all up into small pieces of the pie, if you will, by trying to support multiple and many implementations. And the best analogy is, when the Linux kernel first started to emerge, 20 years ago, there were many distributions that started to pop up, all kinds of people working on this. And it was great. The enthusiasm was fantastic. And if you look today, there's 5 or 6 that matter. And that's where we need to get to with open source implementations, such that we have that critical mass of adoption and support and use, so that these projects have an opportunity to survive. One of the sort of biggest knocks, I think, when people are looking, when we were talking about wading into the pool and being afraid of the water and all that stuff, one of the biggest knocks around open source hardware as a notion in general is that anyone can find a project that's on GitHub that was open sourced, and then it's crickets. Nothing happened. It just mothballed into oblivion, and just argue that, see, this doesn't work. And it's not because there was anything wrong with the design or anything wrong with the technology underlying the design or anything technically. It's about ecosystem development and critical mass, right? So we have a number of initiatives to try to make sure that we are gaining that critical mass and adoption globally. And we talked about a bunch of those, including Open Hardware Europe, Open Hardware Asia, and collaborating with as much of the ecosystem as we can.
I mean, you mentioned geopolitics, and we'll come to that in a minute. But staying on the technology and the sort of adoption, I guess. What's the difference in approach between software and hardware open source development, and does hardware present unique challenges?
Well, yeah, I mean,
I think we talked about this before, actually. So I think we have talked about this before, yeah.
Yeah, we have, but it's interesting. Most hardware engineers have never participated in an open source software project before. So while we as an industry overall have, existence proof that we can draw on and model from our software cousins, so to speak, the actual day-to-day experience of most hardware developers is not there, right? They've never participated in a software development project. So there's that just sort of general awareness and knowledge. They know they exist, but they've never actually interacted and understand how these projects move forward. So
just to interrupt you, I think I remember way back when they always used to talk about sort of the hardware engineers throwing the hardware over to the software over the wall and that happening and then coming back and then going backwards and forwards. It was quite a iterative process, but I guess that's why there's not really that much sort of relation, or wasn't at that time.
Well, and fundamentally, the hardware folks just don't develop the software. So even if it's proprietary internal software or commercial, proprietary software, they're not developing it, and they're certainly not engaged in the open source software projects. So there was no opportunity to even just learn about open source development models. So we had that barrier gap, and then we've talked at length about the tools, right? So there's quite a gap between the types of tools that you need to have and can have, and the availability of those tools to really achieve aggressive time enclosure and layout, tape out, and deep submicron technologies. That those are expensive commercial tools, very expensive. So when you start talking about individual contributors being able to participate in projects, makes it very, very challenging. It's not accessible. So there's that, and that's why we get the open tooling flow question all the time, open source tool flow question all the time. And we have support for Verilator from a simulation standpoint. We have support for different flows that some people are picking up and using, and that's okay, right? It's more than okay. We encourage it; it's fine. But our focus remains high volume production SoCs, right? That's the destination for this IP. That commercial companies will leverage this IP in production, revenue generating products, and the method that they use to sign off on those products and decide to go to production. We're not trying to change those. Until such time as those companies change and sort of narrow that gap and be able to use open flows, which I think will be a while. I mean, this is not insignificant technology, right? I'm not saying it's good or bad that these open source tool flows projects are underway. That's just not a focus for the Open Hardware Group. Again, pragmatically, making sure these guys get to production.
Can you, I think I asked earlier, but the question here, what type of applications can Core 5 processors be used for? What are the trends and other application areas that are beyond the realm of open source? So I didn't ask about beyond the realm, but I definitely asked about the types of applications. But maybe you can just repeat that question. Yeah.
So we'll go from a whole. I think let's cover the gamut in terms of the performance scale, if you will. So the lowest hanging fruit, sort of easiest thing to go do, lowest risk, is using and larger SoC and ASIC. SoC companies, whether their product is SoCs, semiconductor companies, or ASIC teams and large systems companies with very large multi-core designs. Might be using ARM processors or what have you. There are a number of embedded controller cores, if you will, basically programmable state machines, right, to manage clock distribution, power up, maybe SerDes training, and it's entirely embedded firmware. The API is not exposed to the customer or anything, right? It's just a deeply embedded application of a core. Now that might have been a licensed core in terms of commercial IP. That might have been, a proprietary, homegrown, tiny little core, what have you. And in that instance, then that team is also going to be responsible for the software tools on top of it to program the core, if you will, and get it to do whatever it's doing in that SoC. And we have a lot of usage in that model, where there's really no knowledge that there's a RISC-V core, if you will, inside, or an open hardware, open source core from the Core 5 family inside the SoC. And then the next step from there is very similar to the application space for the Core 5 MCU that we've talked about, right? So yes. A low power IoT edge smart device with obviously the programming interface, the API is exposed to the customer or to the user, controlling peripherals on a tiny microcontroller class device. That's also pretty low hanging fruit, easy to do. Relatively. So next up from that, it's application class. Yeah, next up from the application class processors capable of running Linux, or an SMP Linux. So both 32-bit and 64-bit, and our CVA6 family covers this space, that's pretty active work and easily underway with a number of different implementations. There are some companies who already have production products based on the CVA6. Okay. While we continue to work on it, add more features and functionality, and complete the verification the same way that we did with the embedded class cores. And then, of course, there's all sorts of vector accelerators and other purpose-built accelerators to enhance an ML or AI application, as an example, all attaching to both the application class and even some of the embedded class cores that we talk about. And then you start getting into some higher performance space, so server class machines and very high end, out of order multi-core. Doing that in an open source. I mean, this is not for the faint of heart. Those designs are challenging enough as it is, and doing that in an open source domain, I think, is a ways away. Okay. I'm not going to say that you can't do it.
Okay. But so it's not beyond the realm, but it's a way away.
That's a ways down the road. Let's get significant coherent clusters of 64-bit application class cores, under our belt, and see where we go from there. There's lots of work to do in that domain yet. So I think the server space is pretty safe for open source implementations these days.
Okay, well, we're on the top of the hour. I'm not sure if we have time for more, but otherwise, I think, we should try and draw close now.
Yeah, I mean, we like to respect the time slot for the attendees. So again, thanks for doing this, Nitin, and thanks to all of you for joining. If you have more questions that we didn't get to address, and I know there's a few more in the queue, you can reach out to us directly. It's easy to find us. Just Google OpenHW Group, and lots of contact stuff will show up. So thank you, Nitin, and thanks everyone.
Thank you.
Appreciate you. Have a good day wherever your day may be.
Thank you.